welcome back. How did your paddle test go? Here's a sentence that you can use to talk about your paddle test. Add the name of your paddle here is good or not good for pushing the ball into the goal because, and then explain why it is good or not good. So you can use the data that you wrote down when you were doing the paddle test to explain why the paddle is good or not good. Elizabeth, would you like to try it?
Sure. First, I'm going to talk about the tin foil. The tin foil is good. The tin foil is not good for pushing the ball into the goal because it goes slow and diagonally. And the tin foil also kind of damaged itself because it's so thin,
Great, good job, Elizabeth. So pause the video and use this sentence to talk about your paddle tests. Now you need to decide which paddle is best. In the last video, we said that the best paddle pushes the ball fast and straight. If other people where you live tested the same paddle, compare your data to decide. Elizabeth, which paddle do you think is best?
I think this one is the best, the pencil.
Why is that?
Well, because it goes fast and it hits the goal correctly.
Great, good job, Elizabeth. Pause the video to decide which of the paddles you tested you think is best. Did you know that you're doing engineering right now?
What's engineering?
Engineers design solutions to problems and test those solutions. You tested 3 solutions to the problem of how to best push the ball so it goes straight and fast in your game. Now we need to add something else to your game. Let's look back at the video that Ada showed us. How is our game different than the game that Ada showed us? Work with an adult to make a chart like this to describe the differences between Ada's game and your game. Here's the game that Ada showed us. Pause the video and make a chart showing the differences between this game and your game. Here are some differences that we came up with. In Ada's game, the goal is a hole.
In our game, the goal is a cup.
In Ada's game, the puck is flat.
In our game, the puck is a ball.
In Ada's game, the paddle is round.
In our game, the paddle is a pencil.
And it might be something different in your game. In Ada's game, the players block the goal.
In our game, nothing blocks the goal so far.
And you may have had some other differences between Ada's game and your game. So let's focus on the last one. Let's try playing the game with something blocking the goal. We're using this cup to block the goal, and Elizabeth's going to try playing the game. Elizabeth, you seem to be having a problem. What problem are you having?
Well, it keeps going off the game board.
That's a tricky problem. Let's take a minute to think about a solution to that problem. Pause the video and try to think of a solution. Elizabeth, do you have any ideas about a solution to that problem?
Maybe we can make walls for the ball to bump the walls and then go into the goal.
That's a great idea. Let's look back at the game and notice what happens to the puck when it hits the wall. Did you notice how the puck is moving one way and then is moving a different way after it hits the wall? The puck changes the direction it is moving. When the puck hits the wall, it is called a collision. In the collision, the wall pushes on the puck and causes the puck to change directions. But a moving puck or ball is not going to change directions the same way when it collides with every material. So that is why we need to test different wall materials before we start to build our wall. Choose 4 different materials to test. We are going to test tin foil, a piece of a cereal box, a piece of paper folded up like a tent, and a paper towel tube. You could test these materials, or you could test other materials that you find. You can use the same game board that you used in the last lesson. We want to see what happens when the ball hits the wall. To make things more like the real game, tape an upside-down cup in the middle of the board. Now something is blocking the goal. One at a time, tape each material to the side of the board and test what happens when the ball collides with it. If you can, print 4 copies of this sheet to record your data, 1 for each material you are testing. Otherwise, you can use blank paper to record your data. Draw how the ball moved before and after it collided with the wall. So for the tin foil, I pushed the ball towards the wall, and after the collision, it moved like this. For each material that you test, write the name of the material on the sheet or have somebody help you write the name. Tin foil. In the next video, we'll talk about your results. See you then!